So we need to discuss the convergence of the given series. Let's start by rewriting this series a little bit. So this equals the sum of -1 to the power of n over n squared plus 1, where n goes from 1 to infinity. Basically, we have changed our numerator because we know that cosine of n pi, where n is a integer number, the cosine of n pi will always be equal -1 or 1. So that's why this is -1 to the power of n. Well, now we understand that this is an alternating series with an being equal 1 over n squared plus 1. So since this is an alternating series, we can use the alternating series test here. First we need to find an plus 1 minus an. So this is 1 over n squared plus 1 minus, this is 1 over n plus 1 squared plus 1 minus 1 over n squared plus 1. And this equals n squared plus 1 minus n squared plus 2n plus 2 over n squared plus 1 times n squared n plus 1 squared plus 1. Let's simplify it. This equals negative 2n plus 1 divided by n squared plus 1 times n plus 1 squared plus 1. As you can see, this is definitely less than 0, and that means that an plus 1 is less than an. So that means that our series an is decreasing, so every next term is smaller than the previous one, so this is decreasing. And the limit of an where n approaches infinity equals the limit of 1 over n squared plus 1 where n approaches infinity. Since n approaches infinity, then n squared also approaches infinity, and 1 over infinity approaches 0, so this equals 0. That means that from the alternating series test we get that the given series is convergent.